Hey guys, how's it going? This is my my Handin 3 and 4 programming image processing. What you can see here are like some of the variables I use inside my functions. Height and the width of each image on the screen of each recording. These are the arrays, the dynamic arrays that we put our images, our video footage into before manipulating them. And this is a kernel which I use for neighborhood processing. Alright, so let's see what's important here. Right, we put the pixels from the footage into an array, and then we set color image to be set from the array, which we just defined pixels 320, 240, which is the width and the height. This specific part of the code captures an image from the what's it called, from the gray image. It captures a steady picture. And here you can see, and into the array we called output. We get the pixels from the gray image and we put them into the array unsigned char.output. Okay, here's a list of the filters that I've made. I'll go through most of them. So I decided to make a switch case for different keys pressed, and the key press would activate the specific filter. So there's nothing too special here. It's just a basic, depending on what case it is, it's gonna call a different function. So keep scrolling down. Right. Again, just defining what variables, what variable key down is depending on which key is pressed. So keep going down until we get to the functions. And here, apply filter. That's our median filter. It picks an area in the picture, and then it inserts it into the kernel, which we've put inside the function as well. And then we use bubble sort on the pixel to retrieve the median. And this specific number on the bubble sort is it's the number you pick from the sorting that you've made. And this is useful because later we have to find the minimum and the maximum filters, so this is pretty useful. And then the output is the output of this specific pixel is set to the median here. Here's the bubble sort function. Swap values, which is used in the bubble sort. The invert, which we subtract the given pixel from 255 and use that as the output. Brightness, I basically just add a value to each pixel. Contrast, I multiply a value to each pixel. And if we scroll up again, I hate doing this, but okay, you can see brightness is the values of that, contrast is over here, so these are some of the values that are used in the functions. Alright, going back down. Out of contrast, what I did here is basically I told the program that any pixel below below 128 to be subtracted with 15, and a pixel above 128 to be subtracted to be added 15. So except if the pixels is above 255. Log mapping, we use the log to plot the value of the pixel. Same goes for exponent mapping. Gamma correction, it's a funky function. Salt and pepper, you pick a random height and a random width, and the intensity, it determines how many dots there are going to be on the screen. The default I've set it to is 2000, and then you pick a random number between 1 and 0 and you multiply it by 255, so that means it's either black or white. So that's how I decided, that's how I made my salt and pepper. So in the alpha blending, I used the background image that I stored from the grayscale, which is up here. So this is used for the alpha blending. Where is it? And what you basically do is you multiply one of the images with a number between 0 and 1, and the other one with a number between 0 and 1, but they have to add up to be 1. So 0 plus 0.7 plus 0.3, that would be 1. So that works out. This is a function from OpenCV, which converts an image to HSV. Normalized RBG, the filter, what it does is that the given channel is divided by the sum of all channels times 255. So that's what our output is here. Gray to binary is really simple. Just if given a certain threshold, if a value is above it, it's set to 255. If it's below it, it's set to 0. The cosine filter, basically you take the cosine of the given pixel value and multiply it by 255 and use that as the output. Hue shift, we use the function which we defined earlier to change it into HSV, and then as you can see here, 0 is for hue, 1 is for sat, 2 is for value. So the pixel gets changed, and I think the default here is 90. I'll go up and check. Yeah, so the shift value is 90. So, and the hue is like it's 360 degrees, it's a circle, so 90 is a good value to change it with. The saturation change is basically the same as before, but instead of using the 0 channel, we change all the values where we add +1, which changes the saturation instead of the hue. So I looked up how to best define sepia, and this is what I got. So these are the values I used for each channel. Pastels, I looked up on Wikipedia, and what it basically said is that pastel is a less saturated image. So what I did is I multiplied each saturation value by 0.06. By 0.6. That gives us a lighter, less saturated image, which one could argue is more pastel. So I looked up the values of pink, the RGB values of pink, and I gave it a plus minus 5 for each value. So that's what we look for in the image. And the mean filter is all of these neighborhood processing filters use the same kind of code, where you have the for loops, and then you have the loop for the kernels, and yeah. So anyways, there's 5 minutes left recording in this program, so I want to actually show you how the program works. So alright, over here you can see there's a few different screens. Color image, gray image, steady image, and this is just an extra screen I added for erosion and some other filters. So down here you can see what you should click on to activate a certain filter. So if you want to activate brightness, if you have a look here, it got brighter. I'll just do it again. Alright, if you click 2, it's invert. You see. If you click 3, it's it'll add some contrast. 4 is the outer contrast. 5 is the log mapping. 6 is the exponent mapping. You can see the white over here. 7 is the gamma creation. 8 is the salt and pepper. 9 is the alpha blending. You can see over here. HSV conversion. Normalized RGB. Binary image. What else? The cosine filter. Pink color tracking. There's nothing really pink on the screen, or else it would show up. The mean filter, you can see it's a bit blurred. If we use the 7x7, should get even more blurred. Yeah, there you go. Sobo filter, you see down here. Crude filter. Median filter. It's not that visible. The one I really like is the max and the median. You can see here. See, there's a lot of emphasis on the white, whereas if you use a max, which is here, there's a lot more emphasis on the black. So, sorry, and the minimum median, there's a lot more emphasis on black because it selects the minimum value. Emboss with a single kernel, emboss with multiple kernels, the Gaussian blur, erosion, which is down here. This one is just a binary image. Dilate here. Yeah, this one's dilate. Yeah. Open and close. Yeah, that should be about 32 kernels. So yeah, I'm about to run out of time in this recorder, so yeah, that's all I had.